This is the introductory video to Forces of Motion, which is edXL's GCSE 921 Physics Topic 1. And I'm just using a PowerPoint to go through some very basic concepts to make sure that they're covered in the series of videos I've put out in the last few days. I've done the more complex stuff first, which is Newton's laws, momentum conservation, and moments. And I'm now going back to the beginning and make sure that you got enough information that you need to start the topic when you're starting GCSE. So it's like an introduction video, okay? So thanks for watching all the other videos if you've already watched them. If you haven't, they'll be really useful to help you make a concise set of notes for preparation for your GCSE, and before that your mock exam, which for our school will be in January. So don't forget, if you've watched the video, you found it useful, share it with your friends and give me a thumbs up, a like, because that helps with the algorithms on YouTube. And if you subscribe, you'll be notified when future videos are uploaded. So today's video is very basic. It's on distance time graphs. Okay, so what can we get from distance time graphs? So distance time is your position and your movement. So when you move your distance over time, you're moving and your position changes. There is another word I want to make sure you know, and that's displacement. Okay, so displacement is a more scientific word for distance traveled in a certain direction. Okay, so you should all know that distance, speed and time can be calculated using the speed equals distance in meters over time in seconds calculation. They will not give you such an easy equation in the exam, so you do need to remember this. Okay, so I've changed it to GCSE symbols. So V is for velocity, which is a more technical term for speed. Velocity is speed with a direction, but usually we use V for speed. We don't use S. S actually is used for distance or displacement. Okay, so distance without being bothered about direction is in meters, but displacement, you would have to also say that he's gone 60 kilometers north. So you'd also mention the direction that he's moved from the beginning, from his starting position. Okay, and T is always in seconds. Okay. So here's some quick examples. Will walks 200 meters in 40 seconds. What is the speed? 200 divided by 40 gives you an answer of 5 meters per second. Ruby covers 2 kilometers in 1,000 seconds. So remember, if it's 2 kilometers, you've got to change it to meters first. So it'll be 2,000 meters in 1,000 seconds. So it'll be, what is her speed? The answer is 2 meters per second. How long would it take Sophie to run 100 meters if she runs at 10 meters per second? Well, if she runs at 10 meters per second, she'd be close to breaking the world record. Okay, so 100 meters, they've given you the displacement or the distance. She's moved to 100 meters and she runs at 10 meters per second. So to work out time, you got to divide the distance, 100, by the rate of moving, which is 10 meters per second. 100 divided by 10 gives you a time of 10 seconds. So sometimes using the triangle, you have to be able to change the subject of the equation. If you're good at maths, you may not need the triangle. Okay? Then Aaron runs to the shop to buy his FIFA 19. Well, that shows the age of the PowerPoint, because now we're in 2024. And travels at 50 meters per second for 20 seconds. How far does he go? This time you want to work out the distance. So distance is the speed or the velocity multiplied by time. So he's going for 50 meters per second for 20 seconds. So 50 times 20 will give you an answer of 1,000 meters. And then Taylor drives a car at 85 miles an hour. Well, we don't really use miles per hour in GCSE, but they might give it to you, but you will need to know how to convert it, or they'll give you a chart and you'll have to use the chart to be able to convert it. So 85 miles per hour is about 40 meters per second. How long does it take us? So you want to work out time. So to work out time, you need to divide the distance, but be careful because the distance is in kilometers, so it's 20,000 divided by 40. 20,000 divided by 40 gives you an answer of 500 seconds. Okay? So you've got kilometers, you've got miles per hour, you've got meters per second. So one of the tricks is to make sure you are in the correct units for GCSE, meters and seconds. Okay, so there's harder questions here. I'm not going to go through them. If you want to stop the video at this stage, you can work them out. And then in a minute, I'm going to show you the answers. So if you want to pause the video now and try and do them on your own, then you can start the video again. Then you'll be able to see which ones you got right and which ones you may have got wrong. So once again, don't forget to change the units to meters and seconds when you're doing your calculations. Answers are coming up on the screen now. Okay, so that gives you a self-assessment that you can use this video for. Okay, so speed. What are typical speeds when you walk, run, and ride a bike? So typical speeds for walking would be about 1.5 meters per second. Yeah, jogging, yeah, would be about 3 meters per second, depending on how fast you're jogging. And of course, if you're sprinting, the world record is about 10 meters per second, just over 10 meters per second. For Usain Bolt, cycling, you can go faster, and you probably go faster than 10 meters per second, because I'm sure you can go faster than the top sprinter using the advantage a bicycle gives you, especially at top speed. Okay, so what about cars and planes? Well, cars go in kilometers per hour, so you'd have to change the units, but they'll be in tens of meters per second, as we saw in one of the questions before, and aeroplanes go about 800 kilometers per hour, so again you'd have to work it out, so it'll be in hundreds of meters per second. Okay, so when you then want to plot a graph of your position against time, your distance will change and the time will usually go on the x-axis. Well, always goes on the x-axis, and your distance will go on the y-axis. So if you've got a straight line going up from 0 and you've traveled 10 meters in 20 seconds, you should be able to work out what the average speed was to go 10 meters in 20 seconds using the distance, speed, time equation. Okay, so sometimes they'll give you the information in writing, like I gave you in the questions on the previous slides, and sometimes you have to take the data from a graph, which might be a little more tricky, and you could make mistakes. So the first one, the distance traveled is 10 meters, the time taken is 20 seconds, so you'd be able to work out the speed is 10 divided by 20, which would be 0.5 meters per second, the average speed on that steepness of the graph. If you then have a horizontal line and distance time graph, that means your distance isn't changing. So what does it mean? It means you're stationary. So it could be that you're walking, you get to a red light for the pedestrians, and you have to wait for 20 seconds before the light changes so you can cross the road. Now the next line, it's steeper. If it's steeper, it means you're traveling faster. And again, you can work out how much has the distance increased, how much did the time increase, and be able to work out the speed from that portion of the graph. And if you have the line going back down to 0 means you're returning back to your starting position. Okay, so that's a summary of distance time graphs. The first diagonal line, the steepness tells you about the speed. The steeper the line, the faster it is. If it's horizontal, the steepness is 0, so the speed is 0. Okay, the distance does not change. And then the third line is a steeper diagonal line, so it's faster than the speed in line 1. And finally, the diagonal line downwards means that you're returning back to your starting position where you were at 0 distance. Okay, in other words, you're walking back home. It could be considered that way. Okay. All right, so it does give you something about the direction by having the line go back down to 0. Okay, so you should stop the video and in those boxes make notes, sketch the graph, and in the boxes label what each part of the graph tells you. And if you stop the video, watch it again, you'll be able to listen to what I said and make some concise notes for your revision for distance time graphs. Okay, so here's an example with questions. What is the speed during the first 20 seconds? Well, we did that, and the answer was 0.5 meters per second. How far is the object from the starting position after 60 seconds? That's a really easy question. They just want you to read off at 60 seconds. So you draw the line up there with a pencil, you draw a line across, and you get the answer of 40. Okay, what is the speed during the last 40 seconds? So this, you could say it's a negative speed because he's going backwards, yeah? But speed doesn't really have positives and negatives, but if it was a velocity, you could say it was a negative velocity, okay? So you need to do, the speed has changed from 40 to 0, and it took 40 seconds. So what's that speed? 40 divided by 40 is 1 meters per second going back to your starting position. When was the object traveling the fastest? Well, remember, the steeper the line, the faster it's traveling, so it's between 40 and 60 seconds is the steepest part of this distance time graph. Hope that makes sense to you. So I did tell you this is a very basic video to make sure you have understood all of this before you go into the more complex subject of forces in motion. Okay. So here we have a series of lines. There's line Y you just saw is going along the time axis or along the x-axis, and the next one is going steeper, 40 meters in 80 seconds. This one has gone 40 meters in 100 seconds, and this one's gone 40 meters in 40 seconds. So it's about steepness of lines on distance time graphs. So who was traveling the fastest? Well, the steepest one, so that would be G. Who was traveling the slowest but still moving? So that would be N, because Y is not moving because he stays at 0 meters for the full 100 seconds on the graph. Who didn't move? The answer is Y. Okay? So distance time graphs. Now this task is to produce a distance time graph for the following journey, and I'll let you do this on your own. So you basically got to change these words into sketching a graph like the one we had on the previous slides. So Christina walks 50 meters in 20 seconds. So from 0 to 50 in 20 seconds. Then at 20 seconds, she stands still for 10 seconds. So that would be a horizontal line. She then runs away from Luke, who must be chasing her, and covers 100 meters extra in 30 seconds. So that's on top of the 50 meters she's already gone. Remember, in part 2, she hasn't moved. So she's then gone from 50 meters from her starting position to another 100 meters. So 150 meters in total. And then you've got to add up the time to make sure you don't make a mistake, how much time has passed, and plot it as a graph. Then she stands still again and catches her breath for 20 seconds. So that will be yet another horizontal line. And number 5, she then walks back to the start and covers the total 150 meters, which should be the 50 from here, 0 from here, 100 from here. There's your 150. The 2 white statements, she's standing still. So 150 meters walking and running away, and then 150 meters walking back in 50 seconds at a moderate pace. Okay, so that's number 5. So you've got to turn that into a graph that looks like this. It won't be exactly the same. Now, again, these questions allow you to test yourself, so I'm not going to go through them like I did in the previous slide. It allows you to test yourself with your knowledge that you just gained. So they've changed the word from speed to velocity to get you used to the more GCSE terminology. So what was the velocity in the first 20 seconds? So again, you've got to work out in the first 20 seconds how far did the object or the person move in the first 20 seconds. What you can see is 30 meters. And so you can then divide the distance by the time, and you can get the velocity. So this upwards would be positive, and downwards at the end between here and here, she's walking in, the distance is decreasing from 40 to 0, so that would be a negative velocity. Okay? Average velocity, yeah, remember, is the total distance traveled divided by the total time taken, because in the first 40 seconds, first he or she's going fast, then slower. So all you got to do is work out the total distance traveled in the total time taken, and that's how you work out average speed. Okay? And I think you should be able to cope with the other questions on your own. Hope that makes sense. Here are the answers. All right, here's some more questions. So if you want to do this on your own, you can stop the video, pause the video, because when I finish speaking, I'm going to show you the answers. So you may want to stop the video, and before the answers come up, try them, and then start the video again when you want to see if you got the answers right. So I call these self-assessment tasks. Answers are now coming up on the screen. Okay, well that's thanks for watching. That's an introduction to motion, which is part of the Unit 1 EdXL iGCSE Forces of Motion. Yet again, I must plead with you to make sure that you support our channel by giving us a like, sharing it with your friends, and subscribing to ensure that you have all the GCSE videos that I'm going to upload in the build-up to the marks. And I'm going to start with Year 10 topics, but I'm also doing some Year 11 topics for my students as they are doing electromagnetism next. So thanks for watching. See you in the next video. Bye for now.